Thank you to CERN School Labs for this experiment. Every second of every day here on Earth, we are bombarded with high-energy particles. These particles can come from faraway galaxies or from interactions in our own atmosphere. They can range from photons and electrons to muons that are from our frame of reference experiencing time dilation. Today, I'm going to be showing you how to make a device called a cloud chamber. With this information, we can see things that usually would be invisible to us and identify what type of particles they are, all from home. Who needs a science lab? Warning, this experiment uses dry ice. The surface temperature of dry ice is negative 109.3 degrees Fahrenheit. Make sure you know what you're doing and wear protective gear like gloves when dealing with it. For this experiment, you will need a clear container. I taped the sides of the holes of mine so it could be solid. Some type of black metal. I'm using this tray I found. An insulated box, bigger than the metal. I just made mine out of cardboard and a blanket. Hot glue, scissors, a high-powered light, some felt, some 91% isopropyl alcohol, duct tape, some gloves, and everyone's favorite part, dry ice. First things first, we need to prepare the chamber. Measure the bottom of your container and cut a piece of felt to fit the bottom. I double layered mine, so I used hot glue to glue the two pieces of felt together. Then, glue the felt to the bottom of your chamber. Next, we're going to add the isopropyl alcohol to the felt until it is saturated, but not completely dripping. Next comes the slightly dangerous part. Make sure to put your gloves on and go get your dry ice. Put it in the bottom of the insulated box. Now we want to make sure that when the metal plate is put on top of the dry ice, the ice touches the metal, so we get the most heat transfer out of the metal. Next, put the clear plastic container on top of the metal, making sure that the seal doesn't let any air out. Mine didn't completely seal, so I used some duct tape to keep the two together. I brought it up to my garage for minimal shielding by the walls of my house and maximum darkness. Placed something heavy on top to really keep all the air out, and placed a high-powered beam light outside of the chamber. And then I waited, and waited, and waited. What I was waiting for was the alcohol from the top to sink down to the bottom in the form of a gas. When charged particles travel through the cooled gas at the bottom, they will ionize the alcohol, causing it to condense, and the trails of condensation they leave are what we see in the chamber. After what seemed like forever, the tracks of the vapor started to appear. Now it's time to try to identify some of them. Muons and antimuons will have dotted but very straight paths, unless they undergo muon transformation, in which that very straight and thin path will make a very sharp turn. Here's some clips of muons that I found from the chamber. An interesting thing to note is that muons created in our atmosphere alone would not be able to make it all the way to the Earth's surface, but their presence is explained by Einstein's rules for special relativity. These explain that, from the frame of reference of the muon going at very high speeds, time for the muon is actually dilated from the perspective of an observer on Earth. How cool is that? Thin lines that have a little bit more curve to them and or a little bit skinnier can be identified as electrons or positrons. These long, thick lines are alpha particle systems, basically helium nuclei. These mostly come from space outside of the solar system. For example, a supernova. The super squiggly lines like these ones are photons. These come from usually the sun or transformations in our atmosphere, but I did this experiment at night, so there shouldn't be much of anything coming from the sun. It's almost unthinkable how these particles have traveled from almost light years away to make it back to my garage of all places. Science, especially the particle physics variety, can feel largely inaccessible, But this experiment makes particle physics easy to understand and engaging to learn about. All it took was some random stuff I had lying around my house and some dry ice, and we just saw invisible particles that could be from half across the known universe. Now, you know how to make a cloud chamber and can identify the things inside of it. The next time you go outside, look at your hand. A muon just probably passed through it.